Right, so my name is Maciej Korzeniowski. Unless you're Polish, please don't try to pronounce that. I'm not sure whether we have any first aiders qualified in bandaging tongues. I go by Mac for simplicity's sake. I work for a company that has a lot of servers, and lots of servers. Generally, they're sort of divided into groups that the customers approach, what we call the front end. There are sort of servers which call other servers in the middle tier, and then those affectionately known as the back end. Those are usually the ones that are closest to the databases. This is a project from about 2 years ago, but I think it still holds true, as in it's still valuable. I still fire it up every now and then. And I'm hoping to adapt it to our new, ever-growing infrastructure to display. So when I originally designed this, we were tracking about 1,700 production servers. There's one particular product that the team I worked in helped maintain the release code onto the production boxes, and also made sure that everything is running smoothly so customers get a good experience. So there are actually three sort of sets of teams. There's a first immediate response team, which is there 24/7. They're on a shift pattern. And then we had our team, which was kind of reacted to more complicated issues, but also had the access to this monitoring. And then the third set of teams was the development teams, which were kind of the calls for the other two teams existing. But in reality, they're the ones who produce the products. Obviously, there's human error involved sometimes, but we try our best to make sure when things are deployed, they're deployed in a reliable manner. When one thing breaks, you don't need to be woken up in the middle of the night. You've always got that one extra element that can fail, but that's not always the case. So our team was responsible for maintaining a subset, a rather large subset, which accounted for about 70% of the traffic of this particular company. It's an exchange-like product, so if you're not familiar, it's one sort of person says, I would like to sell this at this price. Another person can come up and say, I will accept this bid at this price. So there are, in the case of the scale of this company, there's about 1 million transactions per minute. So quite high frequency, which is why the monitoring aspect is quite important. So we had one tool which all these three levels of teams had access to. So this is me at the office. The screen we see at the end is the dashboards that we had to monitor our services. They're kind of groups. There are about 1,400. I don't know if anybody knows Nagios. It's a open source tool for monitoring servers. Every server can then have multiple services. So all those services that we're monitoring, there are about 1,400 of those. Now, I sat in this team. The team was actually a team of 4 sitting in that row there. I sat at the end. So in order for me to see the dashboard, I had to turn to the left, which wasn't optimal from my perspective of seeing what's just at a glance of what is happening. And that's kind of what the dashboard is supposed to be. I've seen several teams set up dashboards where they've set up many graphs that go on for multiple pages, but then when it comes to displaying it at a glance, it's kind of, you have to scroll through to be able to see everything. That is useful when you get an alert and you're trying to isolate the issue, but the idea is that when something breaks, the first thing is, okay, what changed? Was it a human element? Somebody has introduced a change into one of the systems or the environment? Has something broken in the environment? So it's an unexpected change. So this dashboard was set up by a colleague, as in the one that we see at the end there, which is based off a commercial. You'll probably see it in the presentation. Ops view. It's a commercial product made on top of Nagios. So in this situation, this team of 4, our boss used to sit kind of in there, and for a number of times, he would come back from a meeting, and sort of walked past behind me and said, "Why is this red?" So I thought, well, this has happened twice, say. I need to now take matters into my own hands. I need to be able to see those details sort of closer to my area. In fact, what is on my screen is the detailed view of individual hosts for what's happening there. It's been highlighted in red by the overall team dashboard. So on the right-hand side on the whiteboard at the top it says Go Hack Day. So there was a hack day organized at this particular company, and I took that as the opportunity to put together a dashboard. But what was the thinking process? What were kind of my design goals? Or I like to capture them in sort of limitations, where I don't want to go, so that I know where I want to go. So obviously this is an office environment. My initial idea was my mother-in-law used to have a small store selling school books, exercise books, and a few toys, and she used to have this parrot which would squawk and flap its wings, and I thought that would be the ideal automation project when a priority one incident comes in. That's when things really break. You have kind of P1 alert. But obviously, in the office, that's not probably the best way to alert to failure, regardless of how big it is. There is an alternative. So there's one company which has done something slightly different to monitor their production estate, which we'll see in a moment. But it could be sort of I could use glaring lights to attract attention. That was a little bit. We already had one PC computer running that dashboard which we saw up there. That's probably in excess of 40 watts to just display this. So I thought, well, I would like to cut down on the energy requirements. And obviously I didn't want my colleague to my left had 3 screens, but I didn't want large screens on my desk. The one limitation is, we do have a Wi-Fi network in the office, but it's not, the monitoring elements are not directly accessible due to security requirements, so it would be wired. That means I would need a network. And obviously I didn't want to build too many additional interfaces. So once I had sort of digested all that, I thought, okay, so what I've got is my servers that are working out there. I have this OPSU, this commercial version of Nagios, which is sending me these requests. I will need a network to capture this information. I will need some logic to filter or to process to redisplay it. And the display elements, obviously, I've ruled out audio, so it's not going to be a speaker. It's going to be something visual that I'm going to be using. I thought, so how can I give myself the visual cues I need to when something does go wrong? In addition, how can I quickly identify where did it go wrong? It won't tell me what exactly, perhaps, but at least I can narrow it down. Remember, we're talking about 70% of 1,700 production servers or so. So I sort of worked up in we have a very simple, just an LED light up when something goes wrong. That's not necessarily, a strip would allow me to, we had about 20 groups, so I could have 20 lights. But then you get the labeling issue, or the LED is on or off, or if it's an RGB, you can have it, I guess, multi-colors. That is the Financial Times solution, which they've employed. We'll see that on the next slide, just as a comparison. An LED matrix, so you might have seen those sort of grids of LEDs. And then we can slowly work up in the complexity, in the number of pixels and the number of colors and the physical size. So these are just images of those 3 kind of, I was kind of narrowing it down to roughly one of these kind of solutions. I do own a Pi TFT. I thought that would be nice in terms of size, but that's the full-blown display, and I wanted something that was perhaps slightly smaller, although that would be fine because it is Raspberry Pi sized. So I went ahead and bought this particular display. As you can see, the price is not very, very high. I did not know exactly what I was getting. I did see a model for Arduino. It mentioned I squared C and SPI, which I thought, oh great, I'll have flexibility. I did not know that the picture suggests the controller allows both SPI and I squared C, but the pins that are actually available externally are only for I squared C. So that will come back in a moment. So what I actually did was, once I received this, I did connect it to an Arduino. I was unable to get it displaying a test image. I was getting, so the screen was powering up, I was getting garbage, like noise patterns, but I couldn't actually get it to work. So my next port of call was the Raspberry Pi. It was at that point that I realized, so that one had 4 pins, these ones have varying numbers of pins. So there are a couple of different versions of interfaces if you're looking to try using one of these screens. Sometimes the markings are not immediately clear, but reading up here and there allows sort of the decoding. D0 is the clock and D1 is the actual data. So as I did tests with the I squared C1 and the later, after I had done the dashboard with the SPI, I noticed there's a significant difference in speed. So if you're looking to animate things, like if you wanted an actual gauge from a dashboard, you'd probably go with an SPI, a serial interface, rather than an I squared C. I was fine, I only wanted sort of textual information and changes in status. There is a slight difference in the Python library setup. So once I had my test image up and running, as in I could display something or anything, I could then move on to the actual code, the glue that made it all possible to see what I saw on that big board. So this was the prototype. I actually used this for a couple of weeks and presented it in this form. What we're going to see in a moment is kind of once it's all been boxed up. So I would actually power it off, put that screen inside the, I think this is a Syntec green case, close it up, take it home, bring it back. As I moved it around, I realized obviously the joints on the soldering would crack, which means I had to do a little bit of maintenance after a couple of weeks. So I thought I'd need a more kind of permanent structure, which is where the Pimoroni case, I realized I could fit the screen, so it's just the detail of the wiring. But the screen actually fits in that space very well. This is a revision 1 OLED. So that's the kind of summary of the steps that I took to get here, and I am hoping we have tested the network. Hopefully it will work in terms of actually seeing live data. Hopefully nothing's broken in production. So I'm going to switch to the other 4. Okay, it's not terribly difficult. So as I progressed with the project, I realized I wanted to be able to start the process that would start the display myself. I actually SSH to the box, to the Raspberry Pi, to make that process easier. When I plug in a network cable, remember I needed, I couldn't use it on Wi-Fi in the office. So when I plug in the network cable and power it on, it does run a smart script. It's actually displaying the IP address there, so I can read it off and then I can SSH into it, which I have done here. And so the next stage is to actually try, oh no, actually I need to go, I now need to connect to the virtual private network in order to be able to access that monitoring information through an API. So I am connecting to the VPN directly from that Raspberry Pi. That wasn't the original design I did for the purposes of this demo. I've done that. So it looks like it has connected, and now if I run the it has to be sudo because it requires access to the I2C bus. Then what we should see is a grid. Now, it's not, I think, yeah, we'll see it in a moment. So it is a grid of acronyms of groups of services, which are in normal uninverted text. If something goes wrong, it'll invert the text only for that. I think in the previous slide it showed ANG, one of our services was unhappy and needed some attention. So this strikes a balance between, so remember I started with the concept of I could just have an LED, but this gives me at least an indication of what area I should start looking into. What we don't see, because this was not connected up to the screen, when I SSH, I just get a textual summary of the number of services that are being checked and how many are currently failed. So at the moment it's all zeros, which is why that's all blank. So yeah, so that's actually an earlier. The group has shrunken a bit. So here we have 19, if I'm counting correctly. So it's actually 4 of the services have since been moved or decommissioned, which is why the grid is displayed. I think, so I'm done in terms of the presentation. I will leave I don't know how many minutes we have until the next presentation. I'll leave it running if you'd like to see, because the screen itself, when you see the brightness and the readability, this would sit under my monitors. I would actually see quite quickly at a glance that something has changed on the display. And I did note, yes, it wouldn't have been visible on the projector there, but because this has run for a couple of weeks, you actually do get the OLED burn-in. I'm not sure whether that's because I think I am using the 3.3 volts rather than 5 volts, but possibly the brightness has been overdriven. So, are there any questions? Then I invite you to have a look at the actual display while it's running, and thank you very much.